Hello, I'm Andrew.
And I'm Grant.
We did a Flettner rotor simulation of the Magnus force. So what are Flettner rotors? They are just rotary sails that are used on shipping vessels. It makes them more fuel efficient, and it uses the Magnus effect, which is a reaction to a wind force by a cylindrical object or spherical object to sail. Our model uses this basic free body diagram. It factors in water current, air current, the Magnus force, and a propeller force that is just a constant in a Cartesian reference frame. And wind and water have a variable speed and direction. So as with real life, we vary it in the code as well.
Now then, what were results from this simulation? So if you look, the first thing that we tried was varying the wind speed. As you can see that at very low wind speeds, the path of the boat was pretty much entirely up to the propeller. But as we increase wind speed more and more, as the wind speed is going to the right in this graph, we saw that not only does the boat push further and further to the right, but the force of the propeller is actually counteracted with the Magnus force, as the Magnus force pulls it back down in the y direction. If we look at wind angle, we can see that in this case, the direction that the boat takes is pretty much entirely determined by where the wind is pushing it, plus a little bit of Magnus force put in. And the reason why the line's pointing up or along the line's pointing down is because once again the propeller is trying to push the boat up. Now then, if you look at the next two graphs where we do sail radius, sail height, and sail roughness, all of these graphs look fairly similar because for the Magnus effect, it's linearly related to each of these coefficients. And so as we expect, varying them from low values to high values does increase the Magnus force on our simulation and pushes the boat further down. Thank you for your time.